Welcome. That's the midterm exam review. Thank you for joining me today. If you can confirm that you can hear me, we will start right after. No? You can use the chat box. Okay, great, excellent. Okay, that means I will go through some important concepts covered in these 3 chapters because the midterm exam covers only these 3 chapters. Chapter 1, 2, and 3. Okay. Before I start, I would like to make sure that everyone has an appointment on Examity because the midterm exam is a proctored test and must be taken through Examity. It's still a test on Canvas, however, it's protected by password and some different things. That means you have to take through Examity. Okay? I saw that almost everybody had an appointment, like a time slot booked, but if you still don't have it, please make an appointment as soon as possible because it's not worth to, and it's not recommended to wait until like the last day, Monday, right? Okay, the test will be open tomorrow, Wednesday, and will be closed on Monday. That means that's the time that you can take. During that time, you can pick any time that works for you and take the test. Today will be like a broad review of the midterm exam, and on Thursday, which I know it's the exam time, we're supposed to be a little bit quiet with the questions, but I will still have my kind of like an office hours. I will run the question and answer session. The normal time, 11 a.m. on Thursday. That means if you have the last minute question, you can pop in to the Zoom room and you can ask me a question and I will answer. Okay? And of course the discussion board, but as I said, we have to be a little bit quiet during the examination time. Okay, that means what we have. Oh, actually, one more thing. You probably read my announcement, and in the announcement I did provide a link for the summary of chapter 1, 2, and 3. That means we did type the theoretical part, all of the important concepts, formulas, theorems, definition that we have to know for the midterm test. This review package includes all of the chapters, but of course we have to focus on the first 3 chapters. Okay, that means, and the link is provided in the in my announcement, and I think it's also in the midterm exam module. Okay, that means let's start. Let's see what we have here. I will switch off my video because then we can see the whole screen and what we have. Okay, that means chapter 1. I will not like explain the theoretical part as always because I don't have to really like repeat the textbook, but we know the chapter one was just like the introduction to calculus. We talked about a function, interpretation of the function, average rate of change, a relative change, some applications, cost, revenue, exponential and logarithmic function, exponential growth and decay, composite function, power function, periodic functions. Okay, that means that's what we have to like know and of course apply at the right moment. Maybe understanding the linear function. That means if we will have a point, for example, point A, negative 6, 2, and slope, let's say half. And I will ask you to find the line that has this slope and goes through the point A. Okay? We may use a point slope form, which is y minus y1 m x minus x1. Okay? And we can substitute given points, subtracting 2, slope is half, and subtracting negative 6 is adding. I mean, I can have 1/2 6, 1/2 times 1/2 x, 1/2 times 6 is 3, and plus 2. That means my equation of the line is 1/2 x plus 5. Okay? That means just in case if we have to create an equation, having information. Okay, like what else? We will solve some problems. I'm just trying to highlight the important thing. Exponential growth and decay. Of course, we remember if the base of the exponential function is greater than 1, or if it's then it's growth, or if it's less than 1, of course, still positive, then it's decay. Okay? And we may have some models, exponential models. We remember the p-value, the initial value, and a to the power of t. Some growing or decay, depends what we have. Or we may, a, it's always related to the rate, the growing rate, or the decay rate. That means that's the percentage rate. T, of course, is the time. Okay, that means that's some information for this. Periodic function, like sine and cosine function, we have to be confident with finding an amplitude and the period. That means having a function a sine of bx plus c, or exactly the same a cosine bx plus c. Then, of course, that quantity a, or I can even say the absolute value, is an amplitude. Don't say like negative, always positive. And b will change the period of the function, 2 pi over b. This will be the period. Okay, let me remember these two formulas. Okay, so that's really broad overview of chapter 1. And then chapter 2 is the introduction to derivatives, instantaneous rate of change, derivative at the point, estimating the derivative based on the graph, based on the table, not just based like on the formula. Derivative as a function, a relative rate of change, making the interpretation of the second derivative as a rate of change, and a little bit of application, marginal cost and the revenue cost. Let me remember, marginal cost is the derivative of the cost function. Marginal revenue is the derivative of the revenue function. And I can possibly write marginal cost is simply derivative with respect to the quantity of the cost function. Marginal revenue is the derivative of the revenue function. Marginal profit, we have to just take marginal revenue minus marginal cost. Okay, that means just in case if we have to do this. And then let's see what we have in. Oh, okay, I do have some important, like you can read this, like important skills for the midterm. Like as I said, if sometimes, because we have so many approach to one concept, we have to be flexible. Okay? If one way of looking at the problem doesn't really work, we can always try another. That means we may have a graph, as I said, formulas, we can have a table. We have to understand the meaning of the derivative mainly. That's what I'm talking. Okay, that we make sure that we understand this. Okay, you can read this later, and that's about the derivatives. And then chapter 3. And chapter 3 is just the shortcuts. But we do have a few rules: product rule, quotient rule, chain rule, and power rule, of course, and derivatives of the exponential, logarithmic, and trigonometric. Right? We have to make sure. Oh, everybody has to mute the microphone and switch off the video. Okay, thank you. Okay, that means the chapter 3 is relatively, how can I say, short. We still have to practice. We still have to know all of these rules. I can show you, okay. Logarithmic, exponential, trigonometric, combining with the chain rule, and product rule, quotient rule, and chain rule, and of course the power rule. Okay? And then if we will practice this, we will be perfectly fine. Okay, that means let's see what I have. The midterm test contains 20 problems. Each of them is 10 points. Okay? And the type of the problem is exactly the same like your weekly assignments, weekly quizzes. Okay? That means you can double check, you can go through again from lesson 1 to lesson 6, okay? All of your quizzes, because the test will be similar. Or you can also go through again chapter test 1, 2, and 3. Okay? And all of my weekly sessions also can give you good source of problems. And of course, this session. Okay, let's start. That means what I have, I do have a question 1. Question 1 is asking for the relative change only. That means the number of sales per week of $75.99 pair of jeans is 25 pairs. That means the number is 25 pairs, and that's the price. The number of weekly sales goes up to 45 pairs when the price is reduced by 30.3%. Okay, of course, that means if the price is reduced from 25, we change the sales to 45. And the question is, find the relative change in the weekly sales. Okay? That means we don't have to really focus at the moment at the prices and everything, just the relative change. That's when we remember the relative change. Yeah, that's what you will be asked to compute. We have to know the new quantity and subtract from the original quantity and divide, because we have to find the ratio of the original quantity. That means P sub 0, the original quantity was 25 pairs. The new one, after this, the price was reduced, it's 45. And the difference, we can see that it's like common sense, right? The difference jump like it's 20 more. And how this 20, how can we compare to the original amount 25? That we have to find the difference and take the ratio of the original quantity. That means 20 over 25. Okay? That's the relative change. We're changing by 20 pairs comparing to being 25. Okay? And this looks like we can divide by 5. I can have this, or I can even write 8 over 10, or I can write 80%, because that's what I was gonna write 0.8, but that's also, because it's the percentage, always the percentage. That's in the relative change. The relative change is 80%. And makes sense, right? 20, what percentage of 25 is 20? That's how we will calculate. Okay, but please remember on this slide, relative change, okay? 80%. Okay, now another concept from chapter 1. Calculate the doubling time for the investment earning 8% interest compounded annually. Okay, that means that's our exponential growth. Okay, that's we will have future amount, initial amount, and then 1 plus my rate and time. And this is, of course, rate. And we know that if I will invest $1, I will double $2. Do you remember? Like I can invest, like I will double my investment. 1 plus 0.8. That means I have 2, and 1 plus 0.8 is this. And I have to compute the time in order to double my investment. I have exponential equation, and we remember what to do. We have to take the natural log of both sides. Okay, and then that t will travel in front as soon as I have ln. And now I can divide both sides by ln of 1.08. And that's my time. I know that we can use the calculator, but since on the midterm test we are not allowed to use the calculator, I believe this will be the final answer. We don't have to really, I know it looks weird because we do have some feeling what are these values, but we don't know exactly how many months, years is this. But this is fine, just ln of 2 over ln of 1 over 8. Actually, I don't like writing this way. Always the unknown must be on, okay, on the left-hand side. Okay, that means it's fine for the final answer. Make sure that you can create an equation and put the right things. 2 and 1, double it. If this will be triple, you can put 3. Okay, question number 3. Suppose a firm that produces cookies has monthly fixed cost of $5,000. The variable costs came to $1 per quantity produced, per one cookie, probably, for up to 10,000 quantities per month. Okay, and the firm sells each cookie for $3. Find the firm's profit function. Okay, that means profit, cost. We know what profit is. Profit, and let's say X will be the quantity. It's simply the revenue minus the cost. Okay. Revenue is like just $3 per cookie. And the cost function is telling me that they have fixed cost 5,000 and the variable cost is 1. That means it's 1 times X. Okay? I will make sure that, because if this is not 1, we have to still multiply. Because that variable cost is like a slope of that line. We remember 1 times X. Okay, that means that's pretty much everything. From the profit, from the revenue, I have to subtract the cost and cost of this. It means the final answer will be 3x minus x, 2x minus 5,000. Okay, that means that's, and if we sell like 10,000 cookies, we do have some profit, but that's the function. The function represents the profit. Okay, yeah, we make sure that we know this one. That means each slide, each question, it's quite important. Do not miss any of them. Okay. Calculate the amplitude and the period of the function. Maybe you can tell me what is an amplitude and what is period. Who can tell me A, amplitude? Because I'm just solving the questions. I'm not asking you, what's the amplitude? Do you remember the formula? It's simply 8. Yes, thank you, Rachel. This number, that means one more time, I will just write A cosine bx plus c. That means an amplitude, I can write not negative, remember, don't, because amplitude is just the absolute value of number A, and number A is negative 8, it's 8. Okay, 8. Okay, what about period? Do you remember how to compute a period? What is the quantity B? Who can tell me the quantity B? Looking at this formula. What's the quantity B? Bx, 1/4 x. You don't want to write the answer, it's too easy. Okay, that means B is 1/4. It's important to know how to identify this. And period is simply 2 pi over B. Okay? Because cosine function and the sine function, they repeat every 2 pi. They are like periodic function. That means 2 pi divided by 1/4. Dividing by fraction means multiplying by the reciprocal. 8 pi. It's 8, but just a coincidence. 8 pi. Okay, that's the period. 8 is an amplitude. And we can see this quantity, like the shift, the vertical shift, doesn't really change, doesn't really affect an amplitude of the period. Okay, remember, do not miss this nice question. We do have a limit. I think we did compute a little bit of limits. That means let's try. And we remember we have a limit. Limit means that we have to investigate the behavior of this function close, really close to the point 0 at this point. H is not really 0, H is getting really, really close. We remember this limit has something to do with the instantaneous rate of change. Because the instantaneous rate of change is like a slope of the tangent line, but I can't get the slope between the point and itself. Okay, too theoretical. If I will substitute instead of H 0, if I will put 0, which we call direct substitution, I will actually get -3 squared, which is 9, 9 minus 9, 0 over 0. That means, please remember, the answer is not 0, and I can't do this right away. I am getting 0 over 0, but this is kind of like the instantaneous rate of change, right? Because it's rise over run, no rise, no run. The rate of change at one point. But what this like arithmetically or algebraically means for us to get the answer, having 0 over 0, we know that we do have a common factor between the polynomial from the numerator and denominator. I have to change this. I have to probably expand the numerator and find a common factor h, and then cancel out. That means that I will cancel out that zeros, and then I can substitute again instead of h0. Okay, that's what I will do. I will, of course, copy my limit, and I have to expand this h minus 3 squared. Probably you know that we have to simply FOIL, okay? And we will have h squared minus 3h minus 3h plus 9. I mean, I can copy this. H squared, -3 and -3h is -6h plus 9. And then we have another minus 9. And we can nicely see some simplification. Now, I see on the top h squared minus 6h, I can factor out h. And again, I have a product. That's the main cancellation. H over h, 0 over 0 is gone. That means what's left? Limit as h goes to 0, h minus 6. Now I'm okay to put instead of h 0. The final answer is -6. Right? And this is, we remember the definition of the derivative because this function actually represents the derivative, slope of the tangent. Okay, for the function like x or h, x squared, okay? This will be -6. Okay, but make sure that you know the process of canceling and finding the answer. One more time, do not assume that 0 over 0, it's 0. It's actually not. Theoretically, it's undefined. Yes, but we're finding a common factor and we're making defined. Okay, a little bit of this. Now, another understanding of the derivative, or I would say all of that rates of like change, different rates of change. That means having this graph, let's estimate an average rate of change, instantaneous rate of change, relative change, and relative rate of change at 6 for this function. Okay, that's me. Let's try to find everything, and then we will cover almost 3 or 4 questions. Okay, 6. That means what I will need. I will need, okay, average rate of change. What do you think? I can maybe write here. Average. Oh, hang on. For the average rate of change, I need 2 points, right? Okay, that means I was typing this question. Average rate of change, and let's say on the interval from 0 to 6. Okay, that means 0 will be this corresponding, because for the average rate of change, I have to have 2 points, my initial point and my terminal point, if I can say this. 1 second. I'm sorry, because somebody is. Okay, that means average rate of change on the interval from 0 to 6. You probably know the answer. This will be f of 6 minus f of 0, 6 minus 0. As we can see, it's just the changes in y, changes in x. That means, let's see what we have. F of 6, what is f of 6? F of 6 is, who can tell me this value? F of 6 is 1/2. Yes, thank you. What is f of 0? F of 0 is 3. Oh, thank you, Charlene. Yes, okay, that means that's pretty, because we can see that 3. That's pretty much, that's what we have to do. Rise over run. I will mess up a little bit. Run is 6, and the rise is from 1/2 to 3, 2.5. Yeah, no problem. That means this is negative, of course, because we're going down. Negative 2.5 over 6. What I can do, negative 5 over 2 times 1, 6, negative 5 over 12. Okay, a little bit less than half. And that means that's my average rate of change. Okay, now instantaneous rate of change. Can I spell it? Instantaneous rate of, oh, I'm sorry, my phone is, why my phone's not? Instantaneous rate of change at 6. That means now we remember, we just need 1 point. And instantaneous rate of change could be defined as a derivative. Okay, that's what do you think? What we need in order to estimate instantaneous rate of change? Do you remember? It's, yes, slope. Slope of the curve, or I can say slope of tangent. Okay, that means, look, please look at this. I mean, please look this way at the graph. Okay, I will try to draw a tangent. I don't know if I can do nicely. Oh, my writing. Oh, that's not a tangent. Maybe this. Oh, no, the second part. I kind of stood. Okay, that will be good. Maybe this is 1.5. Okay, that means now having a tangent, I have to just estimate the slope of this line, of the red line. That's what we have. We have rise. Rise is actually 1. Okay, 1. And I'm running away 6. Okay, actually I'm going down 1. That means negative 1, 6. Do you think it's correct? It's 1 here, 1 down, and the 6 units, if I look at this triangle. Okay, negative 1, 6. Makes sense. Now, relative change. Oh, I'm organizing my page, not. Okay, let's say a relative change. Again, this is not from 0 to 6. That means what we need? We need the change between 6 and 0, and how this will relate to the original value 0. Yes, do you remember about this pair of jeans? Like the sales grew from 25 to 45. Okay, that means f of 6, it's 1/2. F of 0, it's 3, and f of 0, it's 3. That means negative 2.5 over 3, negative 5 over 6. That means this is a relative change. Yeah, we have to make it nice. This is this. That's the instantaneous rate of change. Okay, and that's the relative change. Okay, and what we need? We need the relative rate of change. Oh, do I have time? I mean, place, we do have time. Where can I squeeze it? Maybe here. Okay, let's say a relative rate of change. Oh, and I hope you remember it will be the rate of change at 6, the instantaneous rate of change of 6, how this is compared to the original value at 6. That means f prime at 6 was negative 1/6, and the value at 6, it's 1/2. Okay, negative 1/3. Excellent. That means now all of these blue boxes, make sure that you know the formulas. Average rate of change, instantaneous rate of change from the graph, relative change, just the relative change, and relative rate of change. Okay, again, a few things covered. Now I have an instantaneous rate of change, but from the table. Okay. Given the following data about the function f, estimate f prime at 1. At 1. Okay, that's what we can do. We have to go to the right and to the left, right? That means f prime at 1 could be estimated as an average rate of change on the tiny interval, but the tiny interval for us is just the changes by 1. That means I can say f of 2 minus f of 1, 2 minus 1. Or I can go f of 1 minus f of 0, 1 minus 0. That means let's see what we will get. Okay, what is f of 2? Who can tell me f of 2? F of 2 is 9, right? And this is, of course, denominators are 1. And what is f of 1? 5. Okay, 4 over 1, 4. What is f of 1? 5. F of 0 is 1. Oh, wow. That's nice. It's 4. That means I have no option. Because do you remember, if let's say we will get 4 and 6, we can take the average of those. 4 and 6, dividing by 2, 5. But since I got 4 and 4, I have no option. Okay? But remember the formulas. Okay? The f prime from the graph looks like that. Okay, now the graph of the function f of x is shown in this figure below. Which of the following plots is the graph of the derivative? Of course, I didn't copy the options A, B, C, D, and E, but we will get the graph of the derivative, okay? And you know how to check this. That we remember, looking at the function, I will always find a horizontal tangent, because the horizontal tangent is telling me that the derivative at this point is 0. Derivative is 0. Horizontal tangent, slope of this line is 0. That means this will give me x-intercept. This is my derivative. Okay, so my derivative will have x-intercept here. And now, if function is increasing, what is happening with the derivative? Is positive or negative? Excuse me. Yes, do you remember? It's positive. Yes, that means I can say first derivative is positive. Positive means above the x-axis. And we can see it's like from the slope is really, really big and it's getting really, really small because it's approaching 0. That means I'm assuming that that will be the part of the derivative above x-axis because must be positive and it's approaching 0. And then again, if the function is decreasing, first derivative, it's negative. That means everything will be below. And we can see how nice it is from 0 to 0. From 0 to, oh my, let me draw by one go. Yeah. From 0 to 0 because it's steep and then again like 0. And then on this part, it's symmetric, derivative is positive above the x-axis, and the slope is increasing, really huge. Okay, that means it's nice parabola. That's the formula, graph of the derivative. Okay, that means remember looking at positive, negative, and zeros are the most important part. I should put -2 and 0. Okay, another derivative, but the compound function. Okay. Having these two graphs, f and g, let's calculate derivative of f compound with g at 10. That means, first of all, let's differentiate. Derivative of f, which depends on g, times derivative of the inner function. Now everything at 10. Derivative of f of g at 10 times derivative at 10. Okay, what we can do? You can tell me this one probably. G at 10. Function g is this one. That means what's the value at 10? Oh, nothing, yes, nothing really complicated. It's just 10. That means f, but please remember, not always. Yes, not always we will match this. Okay, f of 10. And g prime at 10. Okay. That means now this was just the value. Now we have prime. And we know primes are the slopes. That means what will be the slope at 10 for the function f? That's the corresponding value, and just simply the slope of that line, because the point lies on this line, and this is this line. That's what do you think? What's the slope of this line? Because we need slope. Okay, 1 second. I'm just, okay, -1, because we do have 5, okay, 15 and 50, of course. 15 and 15, it's, that means this is -1 times, and the slope of this line, who can tell me the slope of this line? It's definitely positive, and it's 1, 2, 3, 4, 1, 2, half. Okay, that means the final answer is -half. Yeah, I think you can double check. 20, and this is 10. 10 over 20, half. Okay, but we can see slope. Slope is important. Slope of the line and slope, actually positive half, because negative is from there. Okay, that means you will be good with this one. Another one, because another way to understand the derivative. The following figure shows the graph of f of x. At one of the label points, first derivative, because that's the notation, yes, dy dx, and this is the notation for the second derivative. This is y prime, this is double prime, d squared y dx squared. That's just the, it's not really squared, it's just the notation of the second derivative, are both positive. Which point is it? That we have to find a point, which one? 1, 2, 3, 4, or 5, that both of them are positive. Okay? First derivative and the second derivative. That means what is the condition, what is the shape of the function that the first derivative is positive? Dy dx positive. This means that function is increasing. Okay, right? And the second derivative positive, function is concave up. Yes, we remember this is increasing, and this will be concave upwards. Okay, that's which point is showing me increasing and concave up. What do you think? 4. Oh, Ada. Oh, hang on, we have more answers. Andre said 2. Yes, 2. But I will, yeah, 2 is a little bit, probably, but 2, I would say that 2 is the inflection point, because can you see how this is the moment that function is concave up and then concave down? That means I will say that yes, first derivative is positive, but second derivative is 0. I think you can, I will still accept that answer because you kind of don't know, but it's definitely the inflection point. Okay, now what answer, what other answer? 5. 5 looks actually good because it's increasing First derivative is positive, and second derivative looks like positive because function is definitely concave up. I think our answer is 5. Even 2, I will still kind of say 2 and 5, yeah. This one is definitely, can you tell me what is the first derivative for the first point? 0, thank you. And the second derivative, it is positive because function is. And this one is negative because it's decreasing. Yeah, I think even 2 we can accept. But then the 5 is definitely obvious, right? It's obvious. Okay, you will recognize this. And then what I have, another derivative, but a little bit of application. If the revenue and the cost function RC are given by the graph, sketch the graph of the marginal revenue and the marginal cost. That means we remember, I have the graphs, it's simply a slope. Slope of this line, it's constant. Like we can say slope, which is actually the derivative. I think we can say 1. Yeah, it is 1. Now this one, that means that's the marginal. Yes, that's the marginal revenue. It's just the derivative, slope for the graphic. Okay, this one is cost. Oh, and we have the derivative. Let's see if we can manage this. We can see no horizontal tangents. That means no x-intercept. We do have the situation that function is concave down, or because the function is increasing. That means it's placed it's placed above the x-axis. But let's see, it's concave down, and we have inflection point, and it's concave up. That's when we can see the slope. If I will draw a slope, it's like getting a little bit, it's getting less steep up to that point, which makes sense. It's attaining this point, and the inflection. And then again, it's getting steeper and steeper. That means it's attaining more values, higher values. And this will give me like a minimum slope, because we can see that's the minimum slope, and again, it's steeper again. That means this will be the graph of the derivative. Right? Like everything based on the slope, I would say. That's the important. Or how can we say if, no, it's okay. I don't want to mess up the second derivative, but it's, yeah, and we can definitely get the graph based on this significant parts. Okay, and then I do have some application of the marginal revenue and marginal cost. That means let's try to solve this one. Let CQ represents the cost and the RQ represents the revenue in dollars of producing Q items. Suppose that cost of producing 100 items is $4,000 and the revenue of selling 100 items is $6,500. If the marginal cost of producing 100 items is 20 and the marginal revenue of selling 100 items is 27, approximately how much profit is earned by producing the next item, the 101 items. Okay, that means we know that the profit, it's simply cost, revenue minus cost, which we have 6,500, that's the revenue, minus 4,000, 2,500, okay, quite good profit. However, we still have to look at the marginal profit, okay? That means the marginal profit, it will be simply the marginal revenue minus the marginal cost, which is $27 versus 20. Okay, $7. That's when we have profit of 2,500 and 7, will be because what 7 means? This is $7, right, per 1 unit. It's like a margin, it's like the rate of change. $7 like producing the next item. That we will still keep this profit, okay, and we have to add 7 for profit of 101 items, yes, because we're adding just this rate of change. What will be the profit of producing 5 more items? Who can tell me this? Yes, what will be the profit, the total profit of producing 5 more items? We know how the price is changing, what we have, the marginal profit, of course 35, but we have to remember, we have to add to the total profit. That means 2,500, not 25, 35. Yeah, that will be the number of dollars. Okay, really good. Thank you, Adam. Okay, and then I have, that's almost all of my questions, but what I have 6 or 7 derivatives. Okay, that means now let's take just the function and make sure that we know how to differentiate. And also, do not miss any of them. Okay, that means let's differentiate. The first function is, okay, let's start with easy one. X times, no. Let me write more challenge. T e to the negative 1/3 t. And that's a function, and we have to find the derivative. I mean, please remember, we will not put that product, but you have to realize that it's a product. That means derivative, and let's apply the product rule. Derivative of t is 1 times this function plus t times derivative of the second part. Derivative of e to the power of 1/3 t is the same function, e to the power of 1/3, negative 1/3 t times that exponent, right? We remember it's kind of like a chain rule. Times derivative of this exponent, which is negative 1/3. Okay, let's make a nice order. This is this, negative t and negative 1, I mean positive t and negative 1/3, negative 1/3 t, and my exponential function. I can factor out my exponential function, and I believe that form looks more elegant, okay? But remember to use the product rule, right? Product rule, really important. Just trying to find, because I have the list of, okay, of the function. Maybe I can write this. Product. Okay. The next function is, where's my list? Let's try, okay, maybe we can try this. F of x equals to 140, 1.07, let me put t because it's, okay, something like that. Okay, that means what we have. Carter, you can switch off your video if you can. I will do it for you. Okay. Okay, that means to find the derivative for this function, we don't have a product. We have a constant, 140. We can copy constant. And now we just have the exponential function. But this exponential function is not base e. It's like a to the power of t. That means derivative of this will be just the same function, a to the t, times ln of a. Okay, that means that's another formula. And let's apply. That means I will copy the same function, 1.07t times ln of that number, that base. And we can leave it like that. because the only thing that we will be testing is this formula, okay? And let me maybe write product rule just for you to have it. F prime G, F G prime. Okay, that's when you will have like a reference page. Okay, 2 questions. Yeah, you can get easily 20 points. Okay, another question, another derivative. Let's differentiate this. X to the power of 5. Oh, I don't want to write. I don't want to be. I want your life to be more complicated. X to the power of 5 sine of x over 4. Okay, that's mean again. I will do it. It's still a product rule, but please remember you will not see that dot. But let's try. Derivative of x to the power of 5 is 5x to the power of 4 times the second function. Now plus the first function times derivative of this. Okay, what's the derivative of sine function? Who can tell me this? What's the derivative of sine? Of sine is cosine, and we have to keep the same angle. That means cosine of x over 4 and times that coefficient 1/4, which I can call the chain rule. Okay? And let's make a little bit better order. 5x to the power of 4 sine this, and I can put 1/4 x to the power of 5 cosine of this. I can factor out some common parts, but let's just leave it. Or maybe, just in case, x to the power of 4 actually only. 5, because that's sine function, and this will be x over 4 and cosine. We can't do anything else. Okay, just in case. Okay, but what we did product rule again. F times G, F prime G plus F G prime, and we did the trigonometric derivative of sine AX. It's simply cosine AX times A. Can you tell me derivative of cosine AX? What's the derivative of cosine function? Oh, it's negative sine AX and times A. Okay, let me make sure that you know these formulas. Okay, we did this, we did this. Okay, quotient rule. Let's try to differentiate this weird function. ln of x plus 1, 2x minus e to the x, maybe. Okay? I mean, what we have, first of all, we have to remember is a quotient. Quotient is not easy to miss. You will definitely not miss. I'm always worried for the product. Okay, let's see. Maybe I can write it down for the first time. Quotient rule will be f over g, and derivative is f prime g minus f g prime all over denominator squared. I mean, let's try. What is derivative of ln of x? Who can tell me this? Natural log of x. Yes, 1 over x, thank you. And derivative of 1, of course, is 0. I will write down. Times denominator. And then minus ln of x plus 1. And what's the derivative from the denominator? Who can tell me derivative from the denominator? Derivative of 2x is just 2, yes, and derivative of e to the x is just e to the x, okay? And I can square this. I don't really have to write, that looks weird. I can just put 1 over x. Okay, and let's just leave it because we may have some common factors, but no, I always want to leave it, but doesn't look nice. If I will distribute 1 over x, I will have 2 minus e to the x over x. And then I have to FOIL this 2 ln of x and minus 2, and then positive e to the x ln of x and positive e to the x. Okay, but I believe you can leave it like that. If it's easier, but foiling everything, it's also good skills, but I just gave you because I just wanted to check all of these derivatives. And the message on this slide is the quotient rule. Let me fix my, okay. And I have 1 more or 2 more? 1 more, okay. Function number 5, and we will be done. Let's differentiate cube root of 2x to the power of 4 and just, okay, maybe just this. I just want to check this. Okay, that means what we will do. First of all, we will rewrite this as a 2x to the power of 4 to the power of 1/3. Okay, and now let's differentiate. 1/3, the whole quantity, to the power of negative 2/3 times derivative of this quantity. And the quantity stays the same. Like, do you remember I was doing the U label like before? I think was the lesson 5 or 6. Okay? That we can see we have to copy this quantity. 1/3, the same quantity. Negative 2/3 came from the power rule. I did subtract 1. Okay? And then derivative of the inner function is just 8x cubed. And let's maybe rewrite, that's the chain. We can put 8x cubed over 3 together, and this quantity is taken to the power of negative 2/3. That means we will put everything in the denominator, positive 2/3. But 2/3 means that this is cube root of the quantity squared. That means squared will stay, but with the 3, I will make a cube root. Okay, that looks good. Chain rule, and what I did, I used the power rule. Power rule, which is simply x to the power of n. Yeah, that's what we had. That was my n. N in front, x will stay as a quantity the same, and n minus 1. 1/3 minus 1 is negative 2/3. Okay, perfect. 1 hour review session. And that means I can tell you almost every single question touched the important concept. If you will understand the concept through these problems and you will practice a little bit more, looking at some of the old weekly assignments and of course the review package, you will be perfectly fine. But please put time, please put effort, right? Because practicing a lot will give you confidence and you will master your skills. Okay? Let me thank you for the review session. Please join me for that question and answer session on Thursday. If you will have question, of course, I will be sitting in the Zoom room and I will be ready with my pencil and the whiteboard, and I can answer all of your questions. Okay, the last minute question, or even if it's not last minute question, okay, I can still assist you. Thank you very much. Okay, we do have some questions on the board. Will this be saved? Of course. Oh yes, I'm gonna make the YouTube videos right now with this one, and I will also make a PDF with my writing. This will be posted like half an hour probably I need. Okay, Charlene, thank you. Rachel, thank you. And Andrew, thank you. Ralph, thank you. Janelle, thank you. Thank you very much. And I'm happy that this was helpful. Thank you. And actually, thank you everyone Adam, Carter, everyone, because I think I didn't say all of the names. And thank you for answering my question always. Because you always write, you always looking what I'm doing, you always, yeah, thank you. Okay. Thank you very much, and good luck with your midterm.